So this is chapter 11, and this is all about area, okay, area of all these different types of figures. In this one right here, it's a parallelogram and a triangle. So we're going to find the area of a parallelogram, and we're going to find the area of a triangle. Now, parallelogram may not be one that you learned back when you were a little kid. I don't know, when did you first start learning area anyway? I can't remember. Was it like 5th grade? That's what I was thinking. I was like maybe 5th or 6th. Okay, probably at least 6th grade you were learning about area, weren't you? So I'm not going to go through all the little 6th grade details. Did you ever do that where you had like a rectangle and you had little squares, you know, how many squares can fit in the rectangle, and that's, you know, that's the area and all that kind of stuff. Do you remember doing anything like that? I'm not going to go through all that because you've been through it before. Okay, we're just going to go through different figures and show you how to find the area. Area means all the space that's taken up in here. Okay, if I broke it into little squares, I'm not going to do that, but if I broke it into little squares, how many squares would fit in that, you know, in that figure? Okay, that's what we're doing when we find the area of something. Does that make any sense? All right, I don't want to just assume that you know about area, but I really should expect you to know a little bit about it already before you came in here. So we're going to do area, and we're going to do the area of a parallelogram. And we've had a whole entire chapter, haven't we, on parallelograms? My R's are kind of weird looking, aren't they? All right, so the area of a parallelogram. Well, here's a parallelogram. How about that? We want to find the area of it. What's a real basic, when you were a kid, one of the very first shapes you ever learned was a, what do you think? That has to do with parallelogram. Square, and then you learned what else? Yeah, but parallelogram. Here, look, let's stay where I'm going. Rectangle, okay? Rectangle. You follow me? So a square, but when you're a little kid, I remember my kids had this little puzzle thing, and it had a circle, it had all these shapes, big thick thing, you know, and I remember sitting down there with them and saying, okay, which one's the circle? And, you know, the circle looked like a railroad track, and you're supposed to say, you know, which one's the railroad, or I don't know, whatever it was, but, you know, I was telling my kids, not that it ever stuck, but I'd say, which one's a circle? Okay, and this is a rectangle. And then one was like slanted. I'm like, this is a parallelogram. And, you know, my kid was like, what, 2 years old, and they're trying to say parallelogram, you know. Maybe that's why they hated geometry so much. I don't know. Maybe it's because I forced it on them at an early age. Well, anyway, this is a parallelogram, and it's a, you know, we're learning different shapes. But rectangles, I was asking that question before because of rectangles. You already know how to find the area of a rectangle, don't you? I'm going to put a little R there to represent rectangle. The area of a rectangle, what is that? Just off the top of your head without looking in the book. Okay, you could say base times height. It's not a half, or length times width. A lot of times we learn it length times width, don't we? All right, but you could also think of it as base times height as well. All right, that would be fine. It seems like most people teach it length times width, but what we're going to do is we're going to refer to it as base and height. Now, in geometry, there's something that's very important about the base and the height. They're not just any two sides of this thing. All right? On a rectangle, I'm just going to really quick sketch out a rectangle. On a rectangle, what's true about a rectangle? 4 sides, I understand that, but what's true about the angles here? They're all right angles. So if this was the length, then this was the width. Or you could call it, instead of length, you could call it what? Base, and instead of calling width, you could call it the height. Now, on a rectangle, the base and the height, look, if I could speak, look what kind of angle that they form. It's a right angle. They're what to each other? Give me a big fancy geometry word. They're perpendicular to each other. Exactly right. So what do you think must be true about a base and a height then? They must be what? Perpendicular. Now, here's a 4-sided figure. It's not a rectangle. It's a parallelogram. Okay, but here's a 4-sided figure. And what if I call that right there the base? Then would this thing right here be the height? No, why not? Because it's not what? It's not perpendicular. That's right. So we need to find the perpendicular length. Do this in a different color. Where would the perpendicular length be? Well, it could be from anywhere on the top, because remember, this side and this side are parallel to each other, aren't they? If it's a parallelogram, I could go anywhere here and then just drop down a perpendicular. A lot of people say go straight down. Well, yeah, I know what you're saying, but okay, if you said straight down, you said straight down from the angle. Okay, here's the angle. That's straight. That's a straight line, isn't it? Is that the height? It's straight. I mean, people say that all the time, And you say, well, but I said straight down. That's not what it means by straight down. Well, that's straight, and that's on its way down, isn't it? So technically, that would be straight down. So we don't say straight down. What do we say? We say it's what? Give me the word. Perpendicular. Now, I could have gone anywhere on here. Since it's parallel, I could have just dropped it from here to here, couldn't I? Or I could have dropped it. Now, what if we do this? Like, oh, wait a minute. Where do I go? How far do I go? Well, if I extended that side out, I would just go to where that extension is. Do you remember doing that? Where we put the dotted lines and all that kind of stuff? All right. I'm not going to do that for that one. But any of these lengths right here, as long as they're perpendicular to each other, then those would be the heights. Or that would just be the height. They're both exactly the same, aren't they? Both those lines right there. You follow me? So the area, let's write this down. The area of a parallelogram, I'll just draw a little symbol for parallelogram. The area of a parallelogram is equal to, it's very similar to a rectangle, it's the base times the what? Times the height. That's the area of a parallelogram. But we got to remember about the base and the height. What must be true? What's the relationship between the base and the height? They have to be perpendicular, and that's the key. Now, when you're a little kid in 5th grade, 6th grade, you probably didn't really, talk about it in those terms. But if it's a parallelogram, it's not just the two sides being multiplied times each other, is it? It's this height right here. And sometimes it's a little bit more difficult to find that height. And that's part of the problem. Usually finding the area is not the hard part. It's finding that missing stuff. Like, they might give you the base, and they might give you this side right here, or they might give you this, or whatever. They might give you an angle, and you have to find the height. What do you think could come into play in this stuff that we learned not too long ago? Okay, Pythagorean theorem. What else? Trigonometry. That's right. Okay, you could if you knew this angle right here, and you needed to find the height, right? And you knew maybe this side right here, then you could find the height, couldn't you? But you have to do a little bit of trig. You definitely didn't do that in 5th and 6th grade, did you? All right, they gave you real easy stuff. But now we've learned quite a few things to help us out find some missing stuff. You okay with that? Let's take a look and do an example. All right, here's an example. I've given a parallelogram. This looks a little different, but it's a parallelogram, all right? These two sides are parallel, so are these two. They even showed you this perpendicular side right here, didn't they, to help you out a little bit. And I don't believe they gave you the length. They did give you the length, actually. And they said this is 5 inches, okay, that distance right there. And they call this E. I didn't fill everything in, did I? All right, that's good enough. Now they're going to throw another word at you, okay, besides just area. And it kind of goes hand in hand when you learn this stuff. They talk about the perimeter, and we didn't discuss this, but if I just said, what is the perimeter of something, you really don't have to memorize a whole bunch of fancy formulas. If you just know that the perimeter is the distance around an object, okay, it's the distance around. So if I started walking and I was here at point A, and I wanted to find the perimeter of this parallelogram, it would be this length plus this one plus this one plus this one. You with me on that? That's actually pretty easy. It's not like you have to memorize some kind of fancy formula. You just add up all the lengths of the sides. That's all you do. It's the distance around. That's how I like to say it. It's the distance around an object. Okay? Or I'm just going to say distance around. That's a two-word definition. That's the perimeter. You with me? Look at this. This is a parallelogram. They told us it was a parallelogram. So if this is 10 inches, tell me something else. If AD is 10, Monica, what is it? BC is 10 as well. All right, keep going. What else? Alex, what do you think? DC is 4. AB is 4 inches. You with me on that? All right. Now, to find the perimeter, do you have to have some fancy formula? Not really. What do? You just do what to those? Add them all up. That's right. Can we do them in our head? Yeah, let's do it. That's 10 and 10 is 20. 4 and 4 is 8, so it's 28. So the perimeter is 28. Now, this was in inches, so it's just inches. It's just length. It's the distance that we walked around. Everybody good with that? Yep. Okay. Now we're going to do area. We're going to find the area of this thing. Well, this is a parallelogram. What's the area equal to? It's the base, what? Times the height. Now take a look at this. This is the part that you need to think about. What is the base and what is the height? Remember, the base and height have to be what to each other? They got to be perpendicular. So look to see what's perpendicular. Obviously, right here. Do you see it? So what is this DE, according to my little formula here? What is it? It's the height. That's right. This would be the height. Which one would be the base? The 10, right? The BC would be the 10. You with me? So that's what we do. It's just base times height. So the base, oops, well, actually, it doesn't matter what order you do it in, does it? I'll keep it in the order. Base is what? 10. And the height would be 5. And so what's the area of that whole thing? 50. Now watch. This is 10 inches, and this is 5 inches. So what about my units right here? What's inches times inches? Inches squared. That's good. So we write area in square. You could write square inches if you want. There's all kinds of ways you could write it. You could write square inches. You could write out the word square inches. I personally prefer it this way. Just 50 inches squared. Is that okay with you? It's pretty simple, isn't it? Yeah, I don't think that's a big deal. All right, let's move to something else.